Okay, let's look at question number 6 from the 2022 AP Calculus AB exam. I am Mr. Carboni, and I am solving these in real time. I've never read the question, so you get to watch me process the problem. And we'll see if I have to stop and pause the video or the recording to process something. So let's see, we have particle motion. Particle P moves along the x-axis with that position. Particle Q moves along the y with that velocity. So they gave you the position of P and the velocity of Q. Be very careful with your functions because we have two particles at play here, and it's easy to get them mixed up. And make sure you label them appropriately in your work. At time t equals 1, the position of particle Q is yq of 1 is equal to 2. And I guess I'll write that down. I'm not really doing a whole lot here, but sometimes simply rewriting information they give you helps you process stuff. I don't feel like writing anything else. All right, so find the velocity of particle P at time t. That's it. Just find the derivative of that? Okay. Okay, I think I will write this down. So my position of particle P is 6 minus 4e to the negative t. My velocity of particle Q is 1 over t squared. All right, so A is simply asking you to find the derivative of particle P, the position of particle P. So the 6 would zero out. I'm going to leave the negative 4, and the derivative of e to the negative t is negative 1, e to the negative t, which would clean up to just 4e to the negative t. That's it? That's got to be a 1-point question. I can't imagine them giving you more than that. You do have the chain rule with negative 1. That's all we have to do. That's all we have to do. All right. Number B, find the acceleration. Ooh, here we go. Layered question. Okay, so the first part of this is going to be nice. The acceleration of particle Q would be the derivative of the velocity. So think of that as t to the negative 2 power, and the acceleration of particle Q would be negative 2 t to the negative 3, which would be easier to think of as negative 2 over t cubed. I'm looking for intervals. They do tell you that t is greater than 0. So that's what I was looking for. So t is always greater than 0. And they ask when the speed is decreasing, find all times for which the speed of the particle is decreasing. You would expect this to have like a certain interval, but this is not going to work out the way I was expecting it to. Anyway, so speed. If you want speed to increase or decrease, you need to analyze the signs of velocity and acceleration. So you do not simply look at one or the other. So I'm going to make a note that the velocity of particle Q, which is the function 1 over t squared, is going to be greater than 0 for all t greater than 0. And your acceleration of particle Q, which is 1 over t cubed. No, it's not. It's negative 2 over t cubed. Negative 2 over t cubed. That is going to be less than 0 for all positive t's. And because your velocity and acceleration will always have opposite signs for positive t's, then for t's greater than 0, the speed of the particle will always be decreasing. So the speed, it is q, right? We're not talking about p. Okay, so the speed of q is always decreasing. Decreasing for t's greater than 0 because the velocity of particle q at time t and the velocity, the acceleration of particle q at time t have opposite signs. For all t greater than 0. So do remember, speed increases when velocity and acceleration have the same sign. Speed decreases when they have opposite signs. And it turns out that for all t's greater than 0, I was expecting, when they say find the times for t, I was expecting there to be like speed decreases only from like 0 to 6 or something like that. I wasn't expecting it to be for every t greater than 0. But, that's how it works out, apparently, unless I brain farted that somewhere. All right, moving on to C. Find yq of t, the position of the particle q at time t. And so I do know, and I'm going to rewrite this, the velocity of particle q is t to the negative 2. Therefore, the position, the y-coordinate of particle q at time t would be the antiderivative of that, which is t to the negative 1 over negative 1. Don't forget that there is a potential constant of c added onto that. That cleans up to negative 1 over t plus c. And we now need to solve for c, and we can do that because they tell you that at time t equals 1, that will be the position of particle q is at a y-coordinate of 2. So I'm going to plug in 1. That would be negative 1 over 1 plus c is supposed to equal 2. That means that c is equal to 3. And then I can rewrite my position of particle q as negative 1 over t plus 3. That is it for c. As t moves to infinity, which particle will eventually be further from the origin? And give a reason for your answer. All right, so we're going to do the limit as t goes to infinity of each of the position functions. So the limit as t goes to infinity of xq, or the position, so xp of t is going to be the limit as t goes to infinity. And my position of particle p, I'm going to rewrite it ever so slightly. It's 6 minus 4 over e to the t. And as e to the t goes to infinity, this guy right here is going to approach 0. So as t goes to infinity, this guy is approaching an x-coordinate of 6, which will be obviously 6 units from the origin. Let's look at the same thing for particle y, and we will import our answer right here. So yq of t, and again, I'm going to rewrite the function just like I did for particle x. That would be negative 1 over t plus 3. And again, as t goes to infinity, 1 over t is going to crash towards 0. And this is approaching a y-coordinate of 3. And so we were looking for which one will be furthest from the origin. And I will say that particle p is going to be further because it is approaching a point that is 6 units to the right, while particle q is approaching a point that is 3 units above. So particle p will be further. That is a horrible penmanship. Further from the origin, because, I'm going to kill this dead, because p is approaching an x-coordinate of 6, and q is approaching a y-coordinate of 3. And there we go. That is all the parts. That is numbers 1 through 6, and that is all of the last question on the 2022 AB exam.